Hello there, folks. Welcome to another electronic video. Good evening. Making a little, yes, it's electronic video. I hear somebody hollering out there. Not another one. Jim Asbell is going to put together a little supply for me, and I am going to send him some money for it. He didn't want any money, but he's going to get it anyways. LM317, I think. He sent me a circuit. It contains a tantalum capacitor, a special kind of fuse that he's got. He's got all the parts on hand. And he can work with this small stuff, and I can't. So, what I was going to do is I was going to just take my wall wart, which is right here, and just put a bleeder resistor across it and drop it down to 3 volts and feed this thing. However, the unit that I showed you from eBay would take the end of December to, depends on who I get it from, to maybe into March, April and March. So even though it's not a priority, I don't want to wait forever for it. Jim offered to build it for me. It's not all that much. He's got all the parts on hand. Off camera, I opened this thing up because my intention was to shorten it physically. And that way I can connect it with hot glue on the inside of this panel here and operate the little push button that's on here by way of the front of the scope. And to control the main voltage coming in with the on-off switch, which is right here. So the wall wart can be plugged into the wall, and the power out from the wall wart can be switched by way of the power switch here. So the only thing that'll be on all the time is the linear wall wart. Alright, let me get you on a camera. I removed the little screw, which was quite long, and the back clip. And lo and behold, this whole thing comes apart. I want to get you on a tripod here. I want to remove this spring. That's a negative, but I'm going to leave it on for now. And I want to put 2 wires on that. And that'll go to the output of the thing that Jim is building me. And if I remember, he gave me a PDF of the circuit that he designed, and I'll put that up on the screen for you if I remember. So let's say it's going to go, oh wait a minute, we can't do that. I can't do that because I'm using Sony Movie Studio 13. I'll try to put it. Things don't work good for me like Windows Movie Maker, and I can't use Windows Movie Maker with the MTS files that come out of this camera here. That program won't do it. It has to be Sony. Let's get you a closer look at this here. Hang on. Okay. This is very small. This is the push button here. I think you can see that. Alright, so my intention is, I can find my little screwdriver, or I'll have to use my finger. I don't want to use my finger on something small like this. There it is. Okay. I was figuring on using one of the holes that's in the front panel. Well, actually, there's only one hole. Intensity modulation hole. glue this thing with hot glue to the inside bottom of the panel. This thing is small enough that it'll fit right in there. It's really quite small. And fasten it down like this. So you're looking at the inside of the scope on the back of the panel. This circuit will be exposed towards the back. This part would be glued to the inside of the panel and lined up with the hole. I just have to figure something I can stick in the hole there to push this button. Because you need, when you put power on this, nothing happens until you push this button. It's not one of these things where you can turn it on and off from here by turning the power on and off and having it work. You've got to energize it with this button. I measured the current that Jim asked me to do. It's 180 milliamps. So that thing draws 180 milliamps off of two AAA batteries. I don't know if you can see that. I don't even know if it's upside down. I cannot read that, but take my word for it. The AAAs, I think it shows up in there. 180 milliamps off of two AAA batteries. I can tell you that that thing would not last very long. We'll get you on the back side of this thing. You can see it better with the in this angle here. So it's not a very big circuit. As a matter of fact, there is a tiny transformer in here. You might be able to see it. It's a strange circuit. Not so much, well, I don't even know what the circuit is here. It's a high voltage generator. It puts out, at this end here, 60 volts AC. I don't know the frequency. I didn't bother putting it on a scope. With 3 volts going in here. So I have no idea. I don't think the rope light display on this display scope is LEDs. I think they are probably maybe gas or some kind of neon maybe. I really don't know. Maybe Greg from Greg's Vintage Workshop can tell me what they are, because when he did this, he didn't send me the specs and what it is. I have no idea what it is. Maybe you can tell me, Greg, because I have no idea what it would be. What would require 60 volts AC, and I can't think of anything else but neon. And neon usually takes several thousand volts. So I really don't know what it is. But anyways, you can see how small this thing is. Get the ruler out here. I would say it's about 1.25 inches by 1 inch. Close as I can read it without getting my magnifier up there. So it's not very big. So we'll solder a wire on to here, and that's going to be really hard. I think maybe we'll do is we'll remove this spring here and try to solder to this. Hopefully I can solder to it. So if this material here, the contacts are stainless steel, like the NiCads and the metal lithium, I'm not going to be able to solder them. But if I try to solder to these two traces here, I might bridge it over. But I'm not going to do that now until I get that thing made for Jim. From Jim, rather. Alright, let's see if I can get you. I'll knock on my camera over here. Alright, you see this hole right here? That's the intensity modulation. That's the only open hole on here unless I remove one of these binding posts. Now originally I was going to put an LED in there, but if I line this up, I don't break it getting it hooked into things. If I line this up so that this hole lines up with this button here, which it will if I put it down like this, okay, like that there, hot glue it in place after I make very sure that it's lined up good. That will be good. And I think probably what I will do, and I hope I don't fail on it, because if I get the glue in this button here, you might as well throw it out. Let me get you, if I get this light to hit it, there we go. I was going to take a piece of round plastic and glue an extension button on here about maybe 3/8 of an inch long, so it would stick through this hole. But if I get too much glue on it, it goes around the edge here, it's going to glue this button and it'll never be able to be used. Because I'm not going to try to get into that circuit to make it work. The back came off very easily on this. I was originally going to saw this thing off of here. But I don't need to, it just came right off. Here's the rest of it here. Now what I might do is to saw this here, where that line is, right here, that plastic line. Alright, and then put this back on here. That I might do. Better leave it alone. This is too small for me to mess around with. So that's my intention anyhow. So for now, so we don't lose anything, put this screw on. What the heck? Oh, okay, it's going in. It's going in a little hard. This ain't the best. This is an oddball screwdriver that I got. Hang on a minute, let me get a better screwdriver. Okay, it's not going in all the way because I did not put this back on, and this adds some thickness here. So I just stuck this on for now so I wouldn't lose things. And I'll make that modification, you know, cut it while I'll probably cut this off and I'll put the screw back in so that the whole thing will be protected. So that's the story there, folks. So as you can see, I got one hole here that I was going to put the LED in. Now I can, like I say, I can remove one of these binding posts. As a matter of fact, to make it look uniform, I could remove this one, which says test signal. I can remove this. I mean, these binding posts are good. I could use them for something else, to the old style, and put my LED over here. Or vice versa, I could put that thing here and put the LED over here. I'd like some kind of a light on it to tell me that it's on, and that won't be too hard to do. I think after Jim makes that thing, it's going to be putting out 3.3 volts. As Jim told me, that's pretty much the standard for these things. So a fresh set of batteries in that little thing I just showed you that I took apart, a fresh set of batteries would probably be about 3.3 volts or thereabouts. They're like probably 1.6 full, you know, unloaded brand new batteries would probably read that, each battery. So 3.3 is a good happy medium, and then I could run the LED off of that. I do everything by experiment, so I'll take my resistor substitution box and start up at like about 10 meg and keep going down until I get the LED to light. Because you need a series resistor in series with an LED. And put the LED on that so it'll all operate on the 3 volts or 3.3 volts. So this was just an update on this. I wish that I could, make it a little more fancy and have it operate, but all it's going to do is just show the display like it is. It's off now, but it looks like it's on. And all it will do is give you a continuous light, a fast flashing display, or a slow flashing display. So, other than an on and off switch, there isn't anything else these controls can be used for. So it's for looks. This will be a little quick video. Maybe I'll try to get that up here tonight. Depends how long it takes to render. Oh, here's the circuit that Jim is going to be sending me.